Okay, so this is the video that I promised I would record, and this is supposed to help you with doing problems 1 and 2 of homework 1. And the basic task here is to implement a program which basically implements this high-level language piece of code. And what we want to do is we want to compare prod L to constant 5. And if prod L is less than 5, you would set prod H to -1. If they're equal, prod H would be 0. Otherwise, it's going to be 1. And you can play around with different ideas. And here I have a simple prod L less than 5, but in the homework problem you have an expression of A, B, and C. And A, B, C are defined as using set. These are defined as different addresses. So it could be A set 0x01, for example, B set 0x02, etc. And what we want to do is we want to implement this using assembly language. And I'm going to just start off with thinking about how to perform the operations. And one of the things that I can you can think that you can do is to subtract 5 from prod L, and then take a look at the result. So you wouldn't necessarily want to know what is the difference between prod L and 5, but you want to know if the negative flag was affected, which means that prod L is less than 5, for example. You want to check to see the Z flag is 1, in which case 5 and prod L are equal. And based on those, you would branch to different parts of the code. So let's start doing the code, and then there are going to be some errors intentionally put in, and then we'll fix the code as we go along. So I can start by doing the subtraction. So I can just say move LW 5, and then I can do sub WF prod L. Let me see if I can get rid of this breakpoint thing here. Yeah. So the result here, and of course, I don't want to mess up the value of prod L. And by the way, this is important. So if on homework problems or on midterm exam, I give you a problem like this, and you do something that messes up prod L's value, that would not be correct. So if the code here doesn't say prod L equals something, that means you shouldn't change its value. So you definitely want to put the result back in W so that you don't mess up the value of prod L. And essentially what this instruction does is it says wreg to be equal to prod L minus 5. Okay, and now do I have to look at the order of the operations that I want to do and do exactly this one by one? No, not necessarily. If the result of this whole piece of code is the same as what you write in assembly, I don't care in which order I did these operations, unless your manager says for some specific reason you have to do the same order. So I may as well do this first to see if prod L is equal to 5. So I could simply say BZ, and then I'll define a label that says prod L equal. Okay, and by the way, be careful. If I call this label EQU, that would have a conflict with the EQU that the compiler knows as the equating EQU and set. If you remember, we talked about those. So I'm going to invent a name that is not EQU, and that's P equal. So if it's Z, I'm going to jump to somewhere down here, which is going to be P equal, and I'm implement that later. Now I can immediately go ahead and use another conditional branch instruction, because whatever I did with sub WF that affected status, BZ is not going to affect the status. So I can go ahead and say branch negative, and that would still be reflecting the result of that sub WF. And in B negative, so if the result is negative, it means that prod L was less than 5. So I would say P less, and A p less as the label could be below p equal. It could be above it. It really doesn't matter. You don't have to use the same order as you wrote the branches. So just for the heck of it, I'm going to put p less above it. And if your code doesn't branch here, and if the code doesn't branch here, it means that neither the z nor the n flag were set, which means that I must be in the case of positive. So it must mean that it is greater, right? That means that prod L was greater than 5 because the z flag and n flag were not set. And if it's greater, well, what am I supposed to do? If it is greater, I'm supposed to set prod h to be 1. So how do I do that? Well, different ways of doing it. One would be, for example, do clear f, prod h, and then incf, prod h. Okay. I could have instead done move lw1 and then move wf to prod h, but this may this could work as well. All right, so we are done with the greater part. Now let's implement the p less. So if prod l is less than 5, I'm supposed to do prod h equals -1, and I can simply do that using setf. If you remember, setf does set all the bits of a register to 1, and that would be -1. And if they are equal, I'm supposed to set it to 0, so I can simply say clear f prod h. Okay, and it seems that I'm done, but there is something seriously wrong with this code. Pause the video, think if you can guess what the problem is, and then I'll tell you what the answer is. All right, well, some of you didn't pause. I saw that. So the problem here is, if you're in the greater condition, fine, you didn't branch here, you came here, you set prod h to be 1, but guess what? The PIC microcontroller doesn't know that it has to stop here, and it's going to go ahead and do the set f, and then it's going to go ahead and do clear f. Okay, so no matter what value of prod L you have, you're always going to have the value of prod h 0, because if you branch to p less, you come here, you do set f, and then immediately after that you do clear f. So you lose that -1 that you had. So you have to branch out. You have to skip these p less, p equal. And what I can do is I can just define a label that says after if, and in that after if could be, move LW, could be anything. And what I need to do is just to skip these p less, etc. So I'll do branch after if, and that's going to skip this set f and clear f. I have to do exactly the same thing with set f, and I say branch after if. I don't need to put it here because I will branch after if. I'll automatically go after if anyway. Now, so this is one way of doing it. Of course, there might be other ways of doing it, and especially in the case of your homework, you need to do some computation on the side, maybe store, a minus b or b minus c. I don't remember the exact problem statement. Maybe store that somewhere so that you can do subtractions later. And finally, if you really want to optimize this code, one thing that you can think of, and again, you can pause the video and try to guess what I have in mind, but I can go ahead and tell you what it is. So if you see here, I had a clear f here, right, and then I had another clear f here. So maybe before I even check prod L and check it against 5, maybe I want to do clear f and not even bother branching to p equal. I could just say, branch negative to p less, and then branch if not negative to, the case in which it's greater. And in the greater, you can just skip this clear f thing. Okay. And one more thing is, when you implement if statement, if then else statements like these, you would need a bunch of these branch after ifs, and sometimes you probably need to, rearrange things to reduce the number of instructions, or you could use some of those skip instructions if you're doing the compare. So but you can try to see if you, once you do move LW5, instead of doing subtract, if you do those compare F, skip if equal, would that save you any of the hassles? And especially those things could be useful if, for example, you've already done clear F before this line, and the only thing that you need to do is inc F. So maybe you can do the compare F skip equal, and you skip this increment F instruction. Things like that. So basically, you have to try different instruction combinations and try different methods, and that might give you a better solution. All right, thank you.